Okay, so you're going to be watching this video lecture for a portion of class today. During this video, we're going to cover a few things. First off, you should be with your circuit partners watching this together, and we're looking at Electricity Unit 3 reading number 3. Your homework for today was to answer the 4 questions at the bottom of this short reading, which is a follow-up to the last couple of activities that we've done in class, looking at the flow rate and resistance in series circuits and parallel circuits. So first part of this is going to be going over the assignment. And as we go over it, if you have errors and things that need to be fixed, you need to be taking care of that. And once done watching this portion of the video, you will be turning in this assignment to your sub and picking up a copy of Activity 6. The second part of the video, I'll be going over pre-lab instructions for Activity 6. And then once you are set with predictions and have shown them to your sub, they will okay you to get materials and then conduct Activity 6. Your assignment for Monday is, once you've done the observations, answer the 2 follow-up questions plus write a conclusion for Activity 6. That needs to be ready to go on Monday. So let's begin with reading number 3 here. The first question says, draw a schematic for the following circuits. And we have the circuit with 3-cell battery, 4 round bulbs, all in series together. So first off, the symbol for a 3-cell battery is right here, positive terminal, negative terminal, and we see that we have 4 round bulbs. The symbol for round bulb is, again, a circle with an R, all connected in series. In series, meaning that they are in a single line and form a single continuous conducting path. Now, the next couple of questions, 2 and 3, were to have you draw arrow tails for the circuits and then also bulb rays for the circuits. As you can see here, the arrow tails that I've used are single arrow-tailed arrows. We have conventional charge flow being shown here, going around the circuit, leaving from the positive terminal, arriving back at the negative terminal of the battery. And we'll talk about why a single arrow tail here in a moment. As far as the bulb rays are concerned, we also have a single bulb ray on each side of the bulb, indicating that these bulbs are not very bright. Now, why a single arrow tail and a single bulb ray on each one? Well, if we compare that circuit to what our standard circuit is, and if you think back to reading number 2, when we first saw the arrow tails and bulb ray patterns, a standard circuit has a 3-cell battery pack in it and 2 bulbs hooked up in series. Well, here we have a 3-cell battery pack with 4 bulbs hooked up in series. And so that circuit would result in a charge flow that is less than the standard circuit. As we talked about, when things are in series, the more bulbs in series, the greater the resistance in the circuit, and so that's going to lower the charge flow, and we also saw that the bulbs are dimmer as a result. So this would result in a charge flow that is less than the standard circuit, and this is due to the increase in resistance for the 2 extra bulbs. For the other circuit with 3-cell battery, 4 round bulbs, all in parallel, this is what the circuit should look like. The 3-cell battery pack there, once again, 4 bulbs, each in parallel to one another. Again, when things are hooked up in parallel, we have multiple continuous conducting paths. Here is one continuous path. We could have another one where the charge comes out to here. We could have another where the charge flows out to there, and then a last one that goes all the way out to the very end. So we have multiple continuous conducting paths. Also, as we defined yesterday, these first couple of wires here, the ones that I'm highlighting in green, those are your trunk wires. The other parts of the circuit, the other wires, that I've not highlighted, those would be your branches. So we have 1, 2, 3 branches in addition to the trunk wires at the very beginning. Now, once again, my arrow tails that I've drawn here and the bulb rays are meant to reflect differences to a standard circuit. In a standard circuit, we would have 3 arrow tails and 3 bulb rays on each side of the bulb. Here I have 4 arrow tails and 4 bulb rays on each side of the bulbs. Okay. As we saw in lab over the last couple of days, when you have more bulbs hooked up in parallel, when we have things hooked up in parallel, the more bulbs in parallel, the greater the charge flow, and so that's going to have an effect on the brightness of the bulbs as well. If we look at our reasoning here, hooking the bulbs up in parallel lowers the resistance, so the charge flow is greater than the standard circuit. The bulbs are also brighter. Now, they are brighter when you compare them to the standard circuit. Again, the standard circuit is 2 bulbs hooked up in series. Well, 1 bulb in 2 bulbs in parallel, 3 bulbs in parallel, 4 bulbs in parallel, because they're hooked up in parallel, means that we have less resistance, greater charge flow. So the bulbs in this circuit that I just showed you are going to be brighter than the bulbs in a standard circuit. Okay. The bulbs don't get brighter in the parallel circuit as you add more bulbs. It's just that they themselves are brighter because of how they are connected when they're connected in parallel compared to the standard circuit, which has 2 bulbs in series. Remember, when things are in series, we get greater resistance than what we do for when things are in parallel. Okay, so that's it for going over reading number 3. Pause the video here, finish making any corrections that you need to make, and then turn that into your sub. And once you have a copy of Activity 6, you can come back, start the video, and continue on with the video lecture. Okay, if you have your copy of Activity 6, then you should be looking at these 3 circuit diagrams. We have circuit A, B, and C again. Our focus question for this activity, which we'll jump ahead here for a second, does adding wires in series or in parallel affect the overall resistance of the circuit? Well, so far in talking about circuits and resistance, we have been looking at the wires as not having much resistance. But in reality, because the electrical charge has to move through these wires, it is very possible that they could be having an effect on the resistance of the circuit. It's really the last thing that we've not spent a lot of time talking about. We've talked about the battery packs and how they supply energy to push charge through the circuit. We've been looking at bulbs. We've been looking at the resistance and the different filaments. We've looked at different types of bulbs, how to hook them up in series, hooking them up in parallel. The only thing that we have pretty much taken for granted the whole time is the wires themselves. So that's what we're investigating here. So as far as materials that you're going to need in order to complete this lab, for materials, you're going to need a 3-cell battery pack. You're going to need a compass. Again, the compass is used to measure charge flow, so take all the necessary precautions for using the compass again. You're going to need 2 sockets, 2 long bulbs, and a total of 4 wires. Make sure you have the materials list down. If you need to, pause the video because I'm going to erase it here so that we can talk about the circuits themselves. But you need those. That's your material list. 3-cell battery, compass, 2 sockets, 2 long bulbs, 4 wires. The first circuit here, circuit A, this is essentially our control for activity 6. We're going to have the battery pack, the 2 long bulbs hooked up in series with one another, and then the compass. Make sure you place the compass underneath the same wire each time. It should be the wire that's leaving the positive terminal of your battery pack. So that's what's shown here. Okay. So we're going to hook that circuit up. In circuit B, we're going to add a wire in series into the circuit. You'll notice that between the two long bulbs that we have some extra wire, which is why it looks all wavy. When you're hooking up circuit B in the activity, you're going to be disconnecting one of the wires. So let's say on your control circuit, you disconnect the end of the wire that's connecting the two bulbs together, and then you're going to be adding in this circuit, another wire and completing it. So in between these two bulbs, you should have two wires connected end to end, hooking the bulbs together. So we'll look at then how does adding a wire in series affect the overall resistance of the circuit. That's circuit B. For circuit C, we're going to be adding a wire in parallel. And so this here is the additional wire. You'll notice that the circuit itself really looks like the control circuit in circuit A. In order to add the wire in parallel, the wire here, this is, say, the arrowheads here, the alligator clips, you're going to be hooking these on to the socket terminals. So hook the extra wire hook the socket wire to the, or hook the extra wire to the socket terminals on one socket. Notice that it is the one that is furthest around into the circuit. Okay. What you should notice if you hook it up correctly is that that bulb, whatever socket you've hooked that wire up to, that bulb should go out. So if you've added the wire successfully to the circuit in parallel, whatever socket you're hooking that wire up to, the bulb that's there should not be lit. It will go out. Why it goes out is something we'll talk about later, but that'll be how you know that it is actually hooked up correctly. Okay. Now, as far as your predictions, here's the rest of the handout again. Again, our focus question is, does adding wires in series or in parallel affect the overall resistance of the circuit? You have 4 predictions that you need to make. First one is, how will the compass deflection for circuit A compare to the deflection for circuit B? Explain your reasoning. Again, circuit B is where you're going to be adding wires in series. The second one, how will the compass deflection in circuit C before briefly adding the parallel wire compare to after adding the wire? The third one, how will the brightness of the bulbs in circuit A compare to the brightness in circuit B? And how will the brightness in circuit C before adding the extra wire, I guess it got cut off, affect the brightness? Explain your reasoning. So you need to add all of those predictions there. Under your observations table, you have circuit A and B, circuit C before the wire, circuit C after adding the wire, so make sure you differentiate between those when you're taking the readings. And then the bulb brightness. Remember, I already told you that your bulb brightness for after adding the wire for the last column here should be not lit. So whatever scale you've created for yourself to rank bulb brightness, you should give that whatever you would call a bulb that is out, if it's 1 or 0 or whatever it is that you decided there. Your assignment for Monday is to complete these follow-up questions. And then also to write your conclusion. Remember your conclusion. The answer to that should answer the focus question, including evidence from the activity. So again, once you have finished the predictions, you can go on to that. Last thing, if we go back and look at the circuits here, we'll notice that in circuit A, we do have a 3-cell battery pack, but in circuits B and C, we actually only have 2-cell circuits. Well, we're going to change this up a little bit. We're going to eliminate the 3-cell pack and only use the 2-cell, just like in the other circuits. So only 2-cell battery packs. Okay. No 3rd cell. In fact, your sub will not even have access to that extra battery cell. And if you're asking for one, that means that you did not watch the end of the video. So that's it. Once you're done with your predictions, show them to your sub. If they are all complete, then you can get your materials, get your observations done. Once your observations are done, put everything back and answer the follow-up questions, write your conclusion for Monday. So that's it. We will go over the results, what we had for these circuits on Monday.